Solving multi-step equations, lesson 2-3. So yesterday we were doing one-step equations. Today we're going to doing equations that use more than one operation. We're also going to learn how to solve equations that involve consecutive integers. And we'll talk about what both of those terms mean in just a second. Okay, we're not going to do this Tour de France problem, but just to say that you can, yeah, never mind. Ignore that. All right, next slide. Where did my slide thing go, huh? Okay, we have 3 new vocabulary words: multi-step equation, consecutive integer, and number theory. So a multi-step equation involves an equation that has more than one operation. So it's more than one operation you need to use to solve the equation. Consecutive integers are integers that are in counting order. So -2, comma, -1, comma, 0, comma, 1 are consecutive integers. Or, well, that's a good enough example. And number theory is the study of numbers and the relationship between them. So write those vocab down. You certainly will see them again. And yeah, when you get them written, restart your video. Okay, to solve multi-step equations, here's a couple examples. We have 11x minus 4 equals 29. 11x minus 4 equals 29. So the first thing I do is write the problem down on my paper. Remember, the goal is always to isolate the variable. Sorry, the variable, all right? That means we want to get the variable alone. So that's our goal. Here's our variable, here, right? And that's the guy we want to get alone. All right, so we're going to add, I'm going to start by adding 4 to both sides. I underline that to show that I'm adding these numbers, right, guys? Cancel those out. What do I have left? I have 11x equals 29 plus 4 is 33. And as you guys will remember well from last year, we're going to keep our equal sign lined up and our problem organized, right? Okay, so I'm still trying to get the variable alone. So I'm going to divide now by 11 on both sides, right? And to divide by 11, whoops, stop that. Divide by, oh, bad. Okay, stop. Now let's see if it'll work. Okay, divide by 11 on both sides, and I find out that x equals 3. See, those two cancel out. The x is alone, which is my goal. I've isolated the variable, and x equals 3. If I want to check my work, I take the 3 and put it back in the original equation. 11 times 3 minus 4 equals 29. And I see if that's true. 11 times 3 is 33 minus 4. Does that, in fact, equal 29? Yes. All right. Here's another problem. First thing I'm going to do is write my problem on my paper. A plus 7 equals, oh, a plus 7, excuse me, over 8 equals 5. I'm going to isolate the variable. That's my goal, right? And in this case, our variable is a. So the first thing I'm going to do is I'm going to get rid of that ugly looking fraction or that ugly looking denominator, right? Nobody likes denominators. So if I multiply by 8, or 8 over 1, these two guys will cancel each other out, won't they? If I multiply on that side, I have to multiply by 8 on that side. So that leaves me with a plus 7 equals 5 times 8, which is 40. Now I have a problem that feels more comfortable. In fact, should feel really comfortable to me. -7, -7, right? Those two cancel out. underline to show I've added or subtracted. Bring my a down. It's isolated now, and 40 minus 7 is 33. So a equals 33. I could check my work if I was a very thorough, conscientious, just ultimate student, right? And where there is an a in the original variable, I would substitute 33. 33 plus 7 over 8. Does that, in fact, equal 5? Well, 33 plus 7 over 8, 33 plus 7 is 40, divided by 8, does, in fact, equal 5. So yes, that is the right answer. All right. Here are, oops, sorry, wrong way. Here's some guided practice for you. One of each type of problem that we just did. Good luck with these. Pause the video. Show nice, neat work on your notes so I can see what, so you can, I can see what you're doing, and you can put them up on the board for us tomorrow. Then start the video back up when you're done. Okay. Write and solve a multi-step equation, and we have our real world example here. Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. What was the original price of the skis? Write an equation for the problem, and then we're going to solve the equation. All right, so let's take a minute, and I want each of you to reread that problem to yourselves. Okay. Come on. So, if we think about it, what do we know? We know that it's on sale for 2/3 of the original price. And we know he's going to use a $25 gift certificate. So we're going to subtract that from what he has to pay, right? And we know the total cost before taxes is $115. So we dissect this whole thing. We need 2/3 of the original price. So that'll be 2/3 of the original price here, minus 25 is 115. All right? How does that look? We're going to let P be the original price of the skis. So 2/3 times P minus the $25 gift certificate is the price of $115. So let's find out what the original price is. Now, so all we have to do is solve this, right? 2/3 P minus 25 equals 115. First thing I'm going to do, always get all your whole numbers together, all your simple numbers together first. So don't divide this first. Let's take care of our whole number 25. We're going to get, actually what we're doing is getting our like terms together, right? And like terms. And these two guys are like terms. 25 and 115 are whole numbers, right? This is something that has to do with a variable, some number p. That's not like these guys. So let's get our like terms together first. Like terms together first. You might want to make a note of that so you don't forget. Like terms together first. Okay? Those two 25s cancel out. That leaves me 2/3 p equals 115 plus 25 is 140. Let's see if I can extend my page. So then what are we going to do? We want to isolate the p. P's our variable. So I'm going to multiply by the reciprocal. Get rid of that fraction. Cancels out, right? So that leaves me with p equals 140 times 3 over 2, and that's the same as 140 over 1. Let me move my page up here just a second, guys. Keep that thought. I don't know if I can move it. Maybe if I can get rid of this. Yep, Okay, extend my page. There we go. Okay. So now we have P equals 140 over 1 times 3 over 2. Cross reduce, and we get P equals 70 over 1, right? This is a 1 and this is 70 times 3 over 1. So P equals 210 over 1. P equals 210. What is 210? It's the original price. So, excuse me, let's say, so we'll have to write a sentence. The original price, the original cost of skis is 210 dinero. Okay. Here's 2 guided practice problems for you. I know we are going to see so many more word problems this year. I heard a couple of you groan. Don't groan. We're just going to get better at them, okay? So please try these 2. I want to see an effort to have written both of these problems. All right, I'll be looking for that tomorrow. Pause your video, do them, and I'll see you back in a second. All right, the other thing we're doing in this section is learning how to solve consecutive integer problems. Remember, consecutive integers are numbers like 2, 3, and 4, or negative 111, negative 110, negative 109. Those are all consecutive integers, okay? Oh, and here they've given us examples. So there's ways to solve consecutive integer problems. And those are integers that are exactly in counting order. So if you think of it, if 2 is our first integer, if we add 1 to it, some number plus 1, that would be 3. Some number plus 2 would be 4, and so on. Consecutive even integers, think about that. Even integers are like 0. Oh, please. Stop it. Are like 0, 2, and 4. So if n was our number and it was 0 and we added 2 to it, we'd get to 2, right? If we add 2 to that, we get to 4. So to solve even numbered integers, it's n plus 2, and n plus 4. This will make a little more sense when we actually do a couple problems, so don't freak out about it if you don't totally understand it right now. But I would take the time to write this chart down in your notes. Go ahead and write it down. This is a key concept that we are going to learn. And just by writing it down, it's going to get a little clearer. And then when you watch us do a problem in a minute, it'll even make more sense. Odd numbered integers actually have the same sequence as even. It's just a matter of where we're going to start from. So let's watch and see how that works. So, say what's our little study tip tell us up here? Study tip says you can use the same expression to use even numbered integers and odd numbered integers. We just talked about that. Okay. Our problem here is to write an equation for the following problem, then solve the equation and answer the problem. Find 3 consecutive odd numbered integers. So 3 consecutive odd numbered integers with a sum of negative 51. So I know my answer is going to be negative 51, don't I? All right, that's where we're going to start. What's our first integer going to be? Let's call our first integer, we're going to call it n, all right? Our second integer is going to be n plus 2. And our third integer is going to be n plus 4. So here we have, so n, so if we add 3 consecutive integers, we're going to get negative 51. So we have n plus 2 plus n plus 4. This is our first integer. Here's our second integer. And here's our third integer. And all three of those integers added together equal negative 51. Watch what happens now. How do we solve this equation? N plus n plus, so how many n's do we have? We have 1, 2, 3 n's, right? I can take, maybe it'd be helpful for you guys if I took all the parentheses out. And so now we have n plus 2 plus n plus 4 equals negative 51. I'm going to get my like terms together. I have 3 of them, so I have 3n plus 6 equals negative 51. Subtract 6 on both sides. We're going to isolate our variable, right? 3n equals negative 51 plus a negative 6 is negative 57. All right? I'm going to divide by 3 because I'm trying to isolate my variable n. N equals negative 57 divided by 3 is negative, 3 goes into 5, 1 time, 2 left over. 3 into 27 is negative 19. So my first number, so n equals 19. My second number, right, so the first one is n. The second one is n plus 2. So what's it going to be? 19 plus 2, or excuse me, that's a negative 19, my bad. So that'll be negative 19 plus 2. What's negative 19 plus 2? Negative 17. And my third number is n plus 4, so that'll be negative 19 plus 4, or negative 15. So what are my 3 consecutive numbers? My 3 consecutive numbers are negative 9, or excuse me, 3 consecutive odd numbers, negative 19, negative 17, negative 15. And if you think about a number line, right? 0, there they are, negative 19, negative 17, and negative 15. Okay. You might want to listen to that part of the video again. Otherwise, go on to the next page. And here is your guided practice. Find 3 consecutive, this is just consecutive integers, not odd or even. So since it's regular consecutive integers, it's going to be n plus 1, and n plus 2. Because there's only 1 digit between each of them. If it were odd or even, there'd be 2 digits between each of them. Okay, good luck with that problem, guys. And that is, believe it or not, the end of this video. So good luck, and we'll be doing lots of these problems tomorrow in class, and we'll put all of these that we've done for guided practice up on the board.